Hi all, today we are going to see two questions based on Zener Diode. These two questions are asked in previous year CSIR UGC net examination. The first question is asked in December 2011 in part C. Part C is of 5 marks. In the last video, we have seen about a Zener Diode. Zener Diode acts as a voltage regulator. See this question. The figure below shows a voltage regulator utilizing a Zener diode of breakdown voltage 5 volt and a positive triangular wave input of amplitude 10 volt. For Vi greater than 5 volt, the Zener regulates the output voltage by channeling the excess current through itself. Which of the following shows the current I passing through the Zener diode? Here, the circuit diagram is given with the Zener diode as the voltage regulator. An input voltage is applied. This input voltage is in the triangular waveform that is also given. We have to find out the nature of current that is passing through the Zener diode. The I is the current passing through the Zener diode. In the question, it is also given that the breakdown voltage is 5 volt. Breakdown voltage means Zener voltage that is equal to 5 volt. And a positive triangular wave input of amplitude 10 volt, that is VIN is equal to 10 volt. So here, which of the following shows the current passing through the Zener diode? So we want to see what's the nature of the Zener current. Here Zener current is given as I. Here we are using the concept of on and off state of Zener diode. If the input voltage in this circuit is less than this Zener voltage, the Zener is in the off state. Then when the Zener is in on state, for the Zener to be on state, this input voltage must be greater than the Zener voltage. That is, if the input voltage is less than the Zener voltage, Zener is in the off state and the current passing through the Zener diode will be 0. So in the question, the input voltage versus time graph is given. So from that diagram, we can check where this input voltage is less than the Zener voltage. What is the Zener voltage? That is the breakdown voltage 5 volt. So 5 volt comes here. So check where this input voltage is less than this 5 volt, that is from 0 to 1 second. So 0 to 1 second, this input voltage is less than the Zener voltage, that is 5 volt. And next from 3 to 5 second, again this input voltage is less than the 5 volt. And again from 7 second to 8 second, this input voltage is less than the Zener voltage, that is 5 volt. So from the given triangular input waveform, it is clear that from 0 to 1 second, 3 to 5 second and from 7 to 8 second, the input voltage is less than the Zener voltage. That is, during this time interval, the Zener is in the off state and the current passing through the Zener diode will be 0. Now we have to check in which options the Zener current is 0. Only in option A the Zener current is 0 and in all other options there is some Zener current is flowing through it. So in option A, see that 0 to 1 second the Zener current is 0 and from 3 to 5 second also Zener current is 0. From 7 to 8 second also the Zener current is 0. So the answer is option A. So this is a very simple question without any calculations. From the graphical analysis, we are getting the answer as option A. Only thing we have to clear about the basic concept of on and off state of Zener diode. When the input voltage is less than the Zener voltage, the Zener will be off and the Zener current will be 0. So only in option A we got the Zener current as a 0. That is also go from 0 to 1 second, 3 to 5 second, and 7 to 8 second. The second question, it is asked in December 2017 in part B. Part B question is having 2.5 marks. A Zener diode with an operating voltage of 10 volt at 25 degrees Celsius has a positive temperature coefficient of 0.07% per degree Celsius of the operating voltage. The operating voltage of this Zener diode at 125 degrees Celsius. A Zener diode with an operating voltage, that is Zener voltage is equal to 10 volt at a temperature of 25 degrees Celsius. It is having a positive temperature coefficient that is equal to 0.07% per degree Celsius of the operating voltage. The operating voltage of this Zener diode at temperature 125 degree Celsius is. What is meant by this temperature coefficient? Temperature coefficient shows the relative change in any physical property with a change in temperature. In 12th standard, we have studied about temperature coefficient, that was with the change in resistance with a change in the temperature. Then we have defined the temperature coefficient alpha, and the resistance at a temperature T is equal to the resistance at a reference temperature into 1 plus alpha into T minus T reference. From the general expression of this resistance at a temperature T, the temperature coefficient alpha is defined as the change in a resistance divided by the reference resistance into the change in temperature, where delta R is the change in resistance, that is RT minus R reference. Delta T is the change in the temperature. In analogous with the equation related with the resistance, we can also write the temperature coefficient related with the Zener voltage. So if we consider the Zener voltage, this temperature coefficient is alpha is equal to delta VZ divided by Zener voltage at a reference temperature into delta T, where delta VZ is the change in the Zener voltage, delta T is the change in temperature, and VZ reference is the Zener voltage at the initial temperature. So here this temperature initially at 25 degrees Celsius, then the Zener voltage is 10 volt, and after that when the temperature rises to 125 degrees Celsius, we have to find out the Zener voltage. So we can substitute the given data in this expression. So V is equal to 10 volt. This is the initial reference Zener voltage, and 25 degrees Celsius is the initial temperature. We have to find out the Zener voltage, second Zener voltage at a temperature of 125 degrees Celsius. So what is the change in the temperature? That is 125 degrees Celsius minus 25 degrees Celsius, that is equal to 100 degrees Celsius. Delta VZ we can find out from this expression, that is delta VZ is equal to alpha into VZ reference. VZ reference means initial Zener voltage into delta T. So alpha is equal to 0.07 percentage per degree Celsius into VZ1, that is the first Zener voltage is 10 volt, into delta T is 100 degree Celsius. So on calculating this is 0.07 divided by 100 into 10 into 100, that is equal to 0.7 volt. Now what is this change in Zener voltage? That is equal to V2 minus V1. What we want to find out? The Zener voltage at the second temperature, that is 125 degrees Celsius. So the V2 is equal to delta VZ plus V1. So delta VZ is the change in Zener voltage, that is 0.7 volt, plus the initial Zener voltage, that is equal to 10 volt. So answer is 10.7 volt. So the option C is the correct answer. So in this question, we are using the concept of temperature coefficient definition, that is alpha is equal to delta Vz divided by Vz reference into delta T. While watching this video, if you are finding any error, please put it as a comment so that I can correct it. Also, if you are finding any other easy method, please that also suggest as a comment so that I can also learn from you.